Hello, welcome. Let's try to solve another Leetcode problem. 982 triples with bitwise add equal to 0. So we are given a nums array, and inside the nums array, it's going to be just positive integers from 1 to 1000. So this information is really important. So this is just 1000, and for any of the value, it's going to be the maximum number going to be 2 to the power of 16, and this value is also very important for us to solve the problem. Yeah. So the I and j and k going to be more than or equal to 0, less than the length of the nums, and we just want to check if there's a triple which going to be nums I and nums j and nums k equal to 0. If there's a triple, we're going to count it as 1, and we're going to count the total number of such triples. So how can we solve this problem easily? Maybe you're gonna think about the brute force, if you are going to set n gonna be equal to the length of the nums, you're gonna use it for I in raise n, for j in raise n, and for k in raise n. So this is gonna be n cubic, so it's gonna be 1000 square, 1000 cubic, so it's going to be 10 to the power of 9. Definitely it didn't work. Yeah, so normally we're going to check if nums I and nums j and nums k. So yeah, if they are equal to 0, so we're going to update the result. So finally we're going to return the result. So this is the brute force to solve the problem. We just want to count how many of them. Yeah. Now let me just submit it to check that didn't work. Yeah, because it's going to be 10 to the power of 9. Basically, it didn't work, so it's going to be time limit exceeded. Yeah. Now, if it didn't work, normally we want to optimize the algorithm. As you can see, it is a time limit exceeded. It didn't work. So now we want to optimize. So the optimize idea is normally if we already solved the problem of Leetcode problem 1, 2-sum, normally we're going to use the 2-sum idea. So the idea is that, what about if we can calculate any 2 numbers, but not 3 numbers inside the array? Maybe we just want to check any 2 numbers, but at the same time, we're going to prepare a dictionary. So the dictionary is going to be a decount dict. So this is a counter, and inside it is going to be integer. Now we're gonna delete this line because definitely we're gonna use the n square to prepare the dictionary. We want to put any nums I and nums j inside the dictionary to check that if it works. Yeah. So this is a d and plus 1. So we're gonna count how many of them, but currently we just choose 2 of them, but not 3 values of them. Currently, we get a dictionary. So this dictionary inside the values is going to be nums I and nums j. And I is going to be inside of the range, and j is also inside of the range. Yeah. Now we want to have another enumerator of the nums to check that it is possible. Yeah. So we're going to check. So for n inside the nums, so here we will not use n. Maybe we're going to use num. So for any num inside the nums, so for k and v inside d dot items, yeah. So we want to check if this num and the current value is going to be k. If this is equal to 0, definitely we're going to update the result to plus this value v. So v is going to be the number, and finally we're going to return the result. As you can see, it also works. Now let me just submit it to check that if it can pass. Yeah, as you can see, it passed. Although it is 3 seconds, but this is okay because this is not a difficult way. This is like a medium way to solve the problem. Normally, this is a hard problem, but we solved it like an easy problem. Yeah, we just use the 2-sum idea to solve the problem because if you've already solved the 2-sum in Leetcode, normally this is an easy problem, right? Why we can solve it like this? Because here, for any number, so for any number inside the nums, So this is 1000, 10 to the power of 3 for the time complexity. But here for k and v inside d.items, so this is not 10 to the power of 6 actually, because the number is just 1000. Yeah. So for any number, add another number, it is less than 1000. So what's going to happen is this number must be less than and equal to 1000. So this means for the k and values, for all the cases, so the length of the dictionary is also 1000. Actually, it is not 1000, I'm sorry. It depended on the value of the nums, 2 to the power of 16. Yeah. So for any number 2 to the power of 16 and another number maybe less than 2 to the power of 15, maybe 2 to the power of 15, this number must be less than or equal to 2 to the power of 16. So this means so for this dictionary, the length of the dictionary is going to be 10 to the power of 3 times 2 to the power of 16. Yeah, 10 to the power of 3 is normally it's like 2 to the power of 10. So this means the time complexity is going to be 2 to the power of 26. Yeah, so this is nearly 10 to the power of 7. So this is why it works. Yeah. Now let me just print out the time complexity. You're going to check why it works. Yeah, so 1000 times 2 to the power of 16. Let's just check this number. Yeah, as you can see, this number is just 6 times 10 to the power of 7. So that is why it works, because it is less than 10 to the power of 8. Yeah, I think this is the easiest way to solve the problem. Thank you for watching. See you next time.